All right, so we found the moment of inertia about its centroidal axes here. And we know that Ix about its centroid, and that's what that line on top means, is 1/12 bh cubed. Okay, but let's say the moment of inertia that I'm trying to find does not go through its centroid. Let's say it's the axis xb. All right. And it would be a pain to do the calculus each time we needed to do this to shift the axis, all right? But there's a formula that we can use that is called the parallel axis theorem. Parallel axis theorem. And what the equation states, and I'm just going to write the equation first, it says the moment of inertia about any axis x is equal to the moment of inertia about its centroid plus its area times the perpendicular distance d, and I'm going to put y here squared. Okay? So let's remember these terms here. So we've already found the moment of inertia about its own axis here, which is 1/12, or about its centroidal axis, 1/12 bh cubed. We can also look that up in a table in the book. And then we add the area, and for the case that we have here, the total area, it's h and then b, so that's b times h, and that's the area. And then we need to multiply it by the perpendicular distance y, or perpendicular distance squared. And the perpendicular distance is the distance between these two axes. So you can think of this as dy here. Okay, so that's dy. And in this case, it's h over 2. So we h over 2, and then we square that. And what that comes out to be is 1/12 bh cubed plus bh cubed over 2. And then we can simplify that if we want. It looks like that comes out to be 7/12 bh cubed. And that's an example of how we can shift the axis from the moment of inertia about its centroidal axis to the moment of inertia about its a different axis. Now, we have the same equation for the y-axis as well. So we use the moment of inertia about its centroidal axis plus a dx this time squared. So it's the same area, but it's the distance. Let's say we wanted to shift it from its centroidal axis here in the y direction over to here. This would be our dx squared. We would need to square that. So here. So that is a brief tutorial on how to use the parallel axis theorem.